This is the first episode in a series where I'm going to be re-implementing all of the coding trains, coding challenges in Rust from scratch, pretty much. I'm going to be using the STL2 library, though. So here's the first coding challenge. It's called a star field, and it replicates that star field effect that you might remember from old Windows screensavers. So let's have a look at the code. You can see that there are two files, star and starfield. So star is a class that he's written. It has a function called update, has a function called show, and it has a constructor and some small amount of data that is associated with it. If we look at the starfield file, you'll see that it's a typical processing setup and draw function pair. So inside setup, he creates a bunch of stars, 800 to be exact, constructs them all, and then in draw, he will say the speed is going to be proportional to the mouse's X position. He's going to clear the background with blackness. He's going to just translate to the center of the screen, so that's something that we'll have to implement ourselves because we do not have processing. We are using Rust. And then for every star, it calls update and then show. I'm going to be doing a little optimization here to separate the update logic from the frame rate so that it can be independent, but you could easily just have it in the draw loop. So let's start by setting up our project. I am going to go to my extra drive. Let's see, what do we have in here? I'm going to make a folder called code. Make a folder inside of that called Rust. First of all, let me move this window so that it's not being blocked by the little key display that I have. cd rust. Oh. And let's make a folder called coding train. And let's open this in Visual Studio Code. Here we are. There we go. And let's create ourselves a little workspace after I've fixed the window. So the first project we'll be making is called Starfield. Let's do cargo new. Can I call it with something called starting with a number? No, I can't. Okay. Let's call it episode 1 Starfield. Here we are. We can open the main file and get Rust Analyzer started. There we go. And let's add STL2 as a dependency. Version 0.34 is the latest as of when I'm recording this video. And we're going to add the GFX feature so that we can draw circles and such. And let's also create a little framework here so that we can get ourselves up and running more quickly in future videos. What do I call it? Let's call it STL helpers. Oh, and that was meant to be a library. Let's go in there, remove the main file, make it lib.rs. Here we are. And let's start out with error handling, I suppose. So let's add a dependency on this error because that is a very handy way to define many errors. I believe it's 1.0. Yep. So let's go ahead and define an error struct. called STL error, because unfortunately the Rust's STL crate tends to use strings for error reporting. So we're going to convert strings into specific error messages here. So let's start out by deriving debug and this error. This is the main way that you interact with the this error crate. And this is not a struct, it's actually an enum. So let's get started. What can fail? Initializing STL can fail. And in order to define the error message, we add a little attribute here called error. And we say what happens. STL initialization failed. And then the original error message will get substituted in here for you. If we save that, it shouldn't have any errors. So it is. Let's leave it there for now. Let's add a path dependency on STL helpers here. And hopefully this builds. Looks like we're doing well so far. Unused import. Yeah, let's not use this. So a big thing that I want to define is a function that just initializes STL, creates a window, and does a lot of the busy work for us, because typically the workflow is you say let STL equals STL2 init, and then we're going to use our new error type here, map error, STL error init, like that. And let's also add the anyhow crate for our particular thing here, so that we can return any error the same way. So you create an STL context, you say, okay, let video, STL.video. Let's define a new enum value here. Let's call it init video. There we go. That should all compile. Now let's create a window, but we're actually going to call it canvas for reasons that I'll get into. Start field. We're going to set a width and a height here. Let's set it to be, well, what does Dan set it to here? 600 by 600. And then we have a window builder, so we can set some attributes here. Do we need any of these? Probably not. So let's just build. And that can have an error, so we will add a question mark there. Then we're going to convert it into a canvas. And we have more builder arguments here. I'm going to go ahead and add the present vsync attribute. But of course, that's optional. And then building the canvas itself can also have an error, so we will add a question mark again. And you can see that this is the general things that we will need. A canvas to draw on, and then we'll also need an event pump to grab events such as mouse motion, people closing the window, that kind of stuff. Event pump. We take the STL context, get the event pump, and then we have another error here. I'll just call it event pump, just to be short with names. There we go. And then the typical workflow is you would have a main loop, and I like to call it with the lifetime main. And then we go through the event pump and check all the events. and then we pattern match the event. And break the main loop if it's a quit event. I'm gonna add a use here just to make things a little bit more readable. And then finally, we will use the canvas here to draw a black screen and show it. And this is your typical SDL program. You can see that we've already written 28 lines of code without doing anything, but I can run it. Ta-da. And when you hit the X button, it does actually close the window, which is what the event handling here is necessary for. But let's start making this a little bit easier to manage. First of all of this, the only thing that's actually useful to me here is this part here, the width, height, and the title. We don't really care, about any of the rest of this. So let's start by grouping the parameters here. Well, first of all, let's write a function that does all of this for us. I'm going to delete all of that code, and you'll see that we get some errors, but that's okay. And we'll create a function in the library, init STL. Title will be a string. Well, let's not care if it's formatted or not. That's how you write that in Rust. You just say that it can be taken as a reference to get a string. And then we take the width and height. And what do we return? We return... I've forgotten to actually add SDL2 as a dependency here. Whoops. There we go. So it returns the SDL context. We say video subsystem also is returned. Canvas is returned, specifically a window canvas. And there's an event pump. You can see that's one heck of a signature, so we're just going to auto format that. There we go, that's a little bit easier to parse. And let's just paste all that code. There we go. And this is not actually the tuple itself, it's a result of that, or some STL error. Does that compile? It does not, because these here could be errors, and they are not in our STL error enum. So this is a window build error. So let's go ahead and add that to our enum. There we go. And there's another error here. This is an integer or STL error. So we will call that create canvas or canvas build, just to be consistent with window build. There we go. You can see that this is still not compiling, and that's because you're not actually able to convert from an integer STL error into our STL error enum. In order to tell this error to automatically create that for us instead of doing it ourselves, because it's a bit tedious, we can just add the attribute from here. And you can see that one of those errors goes away. All we have left is the window build error, so we'll add from there too. I'm not going to add from on string because that is a bit generic. And if we do that for all of these, then when we're trying to convert it from string, it won't know whether to do init video, or event pump. So we'll stick with the map error stuff for now. And finally, once we've constructed all of this stuff, we will return it in an OK. SDL, video, canvas, and event pump. And you can see that these do not need to be mutable because we are passing ownership onward without doing any mutation. And there we go. That looks like a pretty good function. Let's call it and see if it works. So we don't care about the STL context. We don't care about the video subsystem itself. They're just used to create the canvas and the event pump, respectively. Equals init STL. We give it a title, star field, width 600, height is also 600, and there you go. Now we're down to 21 lines of code. That's pretty good. Also, we can delete this. Let's run it and see if it works. Of course, in Rust, if it compiles, it usually works the first try. Maybe I'm being a bit facetious there, but it did work in this case. So let's start cleaning stuff up. First of all, width and height are two independent integers here, but really we want to kind of represent that these are paired to each other. So let's create a vector struct or something that stores two integers and associates them with each other. It could represent either a size or a position on the screen. This will be useful later. So we'll create a module here just to be nice and separated. Rust Analyzer helps quite a bit here. Alrighty. Let's create our vector struct. I'll call it vector2 because it is two-dimensional. And it's going to store its values as floats. Again, this will be useful later. And these will also be public fields. And let's generate a new function here. Again, Rust Analyzer coming to the rescue, because I don't want to write all that. And that's good enough for now. So let's change this. Instead of taking two integers, we're going to take a vector. Import it. There we go. So instead of, oh, well, I've actually got a bug here. I forgot to change this out for title as ref. This is going to be the width. So that is size.x as u32. And this is size.y as u32. Should compile. And it does, except over here now we've broken our code because this is no longer two separate integers. This is a vector. And it's going to be 600.0, 600.0. There we go, let's run it. Works. Let's do a little bit more cleanup. I don't like this pattern match because all we're doing is checking if it's a quit event or not. So let's do something that Rust lets us do and define an extension method or a trait. And we'll call it event extension. Is quit. Here we go. Now in order for that trait to actually work, we have to implement it. And let's do a pattern match here. If it's a quit event, then it's true. Anything else, it's false. Pretty simple stuff here. So let's go ahead and use that. Instead of this, we just say if event is quit, break the main loop. Let's run it one more time just to make sure. Works great. And then I think we're ready to start actually writing our code. Funny concept, I know. let's look back over at this code here. So he starts out by creating stars. So I suppose the first thing we should do is define what a star is. Here it is. Quite a long file, but mostly because of the paragraphs of comments that Dan has put here. Let's create a module. Oops, I didn't mean to hit that. My bad. Mod star. It's visible to the super module, which is main. I prefer to keep things at the minimum visibility that they need. And in this case, we don't even need pub create because it's just public to the main module. So let's see, what do we have again? We have an x, a y, a z, and a pz, which is the previous z value. He uses this to show little streaks behind the stars. As they get faster, the streak gets longer. Let's say x is a float, y is a float, z is a float, previous z is also a float. Let's define a new function or a constructor. What does it take? Nothing. It uses randomness. So let's include the rand crate since we will need it. What's the latest version of rand? I don't remember. 0.8. I think this was released fairly recently, 0.8. And it does change the API. So we'll take the thread random number generator and we will generate in a range from 0 to the width. As you can see, this is actually not how he does it, so let's copy that. And again for y, except instead of width, it is height. There we are. Let's import the RNG trait so that we can actually do randomness. What's wrong here? Expected one argument found two. Yep, this is the API change that I was mentioning. You use a range instead of the comma. And now it's going to go between width over 2 to width over 2. Z is going to be also a random number. I believe it's from 0 to width over 2. Yes. And we'll define width in a second. PZ is going to be whatever Z was, so we actually have to introduce a variable here. PZ is Z. And let's go ahead and define width so that we don't have these little errors popping up. Also going to add point O's between everything here because they need to be floats. And unlike in languages like C++ and Python, Rust requires that you have a floating point number, literal, in order for it to be considered floating point. You can't just type 2. So let's define some constants. Width is 600, and it's a float. Height is also a constant, and it's 600. Let's replace these 600s in here with width and height, just for consistency purposes, and then we will import them here. And it looks like we're almost back to compiling. What are we missing? 2.0. There we go. So now we can construct a star. Let's do that. So we'll say let stars equals, how many were there? 800. So we're going to do a little bit of functional programming here, and we'll say in the range from 0 to 800, we're going to map. We're going to ignore the actual value of the integer. And this is basically just saying, for I in 0 to 800, ignore I. And if you've used Ruby before, it's similar to the 800.times construct. And we will say, okay, star new, and we're going to collect all of these into a vector. And you can see that stars is inferred to be a vec of star, which is exactly what we want. What else is in the star class? We have update. So this is the thing that I said was going to be made frame rate independent. I will do that in a minute. Let's copy that and paste it, and then translate it. It takes a mutable reference to self. If self.z is less than 1 as a floating point, we don't need these parentheses. This is all caps because it's a constant. Also these. Replace all of these with 2.0. Oops, I did that wrong. Bim find and replace does betray you sometimes. And instead of random, it is rand thread rng gen range. We use dots here. Here we go. Self.x, self.y, self.bz, self.z. Now speed is something that we don't have defined here. How about we pass it in? And there we go. And we will go ahead and replace with minus equals. Thank you, Clippy. That's update. I'll delete his comments so as to not plagiarize. That doesn't work on college assignments, by the way. And we have a show function. So let's copy, paste, and translate. It takes a self, and we're going to need the canvas. There we go. We need a fill function, but we actually don't. But I might as well use it. We're going to use a trait again to create an extension method on canvas called fill. So canvas, fill, color, white, because that's what 255 means, is white. You can see that we have an error here, so let's go to our library and fix that. Bug trait canvas extension. Fill takes a mutable reference to the canvas. It takes a color, and it returns a result of either nothing or an STL error, because I think clearing can fail. I'm not entirely sure though. You know what? It can't. So it's just that. I need a generic parameter here for the render target, because theoretically speaking, canvases don't have to go to a window, they can go to anything. Let's implement the method. And yes, let's go ahead and not use STL to render canvas. We'll just say canvas. Import color. And we will say, this is a two-liner method. We set the draw color and then we clear. Not canvas itself. And there we go. We are all set there. So all we need to do is import the canvas extensions. No stroke in processing means that when you draw a circle, it will not use an outline for the circle. This is actually the default in STL2, and it's impossible to have it be outlined automatically. You have to call fill circle and then draw circle in order to get that functionality. So this is completely unnecessary. So then we create some variables called sx and sy. And we have a map function here. First of all, let's add selfs here where they're needed. So basically what we're saying is whenever we say map, we say we take a value, for example, x over z. We say what it goes between, which is 0 and 1 in this case. And we say what we want it to go between, which is 0 and width over 2 in this case. And let's also make that all caps. There's an extra semicolon on the end here. I'm not sure how that got there. So let's create a map function in our library. Value is a float. We'll say original min, original max, new min, new max. And it returns the new value. So we say in order to do this, value times new max minus new min, to scale it by that value, divide it by original max times original min. So basically, we'll take value, we'll divide it by its original range to get it between 0 and 1, and then we will scale it to be between 0 and new max minus new min. Then we add new min. And there we go, that's the function for map. So let's include it here. You can see that these all need to be floating point literals. I really wish there was an easy way to do this, but unfortunately there isn't. We say let r equals map z from 0 width over 2, and it wants to be between 16 and 0. That's the size of the star, is the radius of the ellipse here. And then he calls a function called ellipse here. The equivalent, since he's set the radius in the x and y directions to be the same, this is actually a circle. We'll say canvas.fill filled circle. And we need to import the STL-GFX stuff. And then it needs 4 16-bit integers. They are sx, cast it, sy, cast it. We need the radius, which is r, and we need the color. I believe it's white. Now, I've actually made a mistake here. First of all, this is not what fill meant in this context. That's actually the background method in processing. So I'm going to go ahead and rename that to background. I was hoping that Rust Analyzer would work with me there, but it isn't. There we go. Ah, it did rename it here though, thank you. So what fill means is not this. It means set the drawing color or the filling color. So we are going to go ahead and do that here. Let px and py, this is all self. These are all floating point literals. These are constants. And these are also floating point. we update self.pz here. So it actually needs a mutable reference to self, which is a bit unfortunate, but I guess that's how it is. Stroke is another function like fill, and it sets the stroke color. So if you have an outline circle in processing, the background is set by fill, and the foreground or the outline is set by stroke. So here we're saying we're drawing a line that is white. So I'm going to delete that, and we're going to say canvas.aaLine ex, cast it, py, cast it, sx, cast it, sy, and also cast it. And its color, white. Now we should get some warnings saying we forgot to return a result, and the show actually can fail, which is if the internal STL function fails. Result of nothing or an STL error. And we're going to map the errors here. And we're going to call that draw, because this is an error that occurred while drawing. Forgot the question mark here. There we go. And this is the wrong line to be doing that on. Toss the semicolon. All right, all that's left is we need to add draw here. Let's keep the strings together. And there's our error. And finally, we need to return OK of nothing, just to report that everything went fine. There we go. I think that's our star class roughly finished. Delete the comments. And let's go back to main. And let's look at his main. So he says size 600, 600, which we've done. We create a bunch of stars and append them to a vector, which is what I did with the functional style programming stuff. We set speed to be mapping mouse x from 0 to width to 0 to 50. In order to do that with STL, we need to store some state. So let mute mouse position is a vector 2, and it's going to be 0, 0 to begin with. And we need to do some pattern matching here. If let event mouse motion x, y, and some other properties that we don't care about equals event. We need to import this. Then we say mouse pause.x is x, and we cast it to float, just because vector 2's are floats. And there we go, we've stored the mouse position. So now we say what? So we set that to be speed. This is a global variable that he's using here, but we will make it local because we are good programmers and good boys. Let speed equals map. That's the wrong map. I don't want that one. Where is it? It's not even listed. That's okay, we'll import it later. Like now. Mouse pause.x goes from 0 to width. And we want it to be between 0 and 50, I think it was. And now let's do that frame rate independent logic that I was talking about. So we will create a struct called timer. And go to it. We need the chrono crate actually. Not 0.4. And we need to store a couple of things here. Last tick, which is a time point, which is a date time in the local time zone because we don't care. As long as we're consistent, it won't matter. And then we need what exactly? Well, let's start with this. Oh, we need the interval, right? Because that's how often we need to tick. So, simple timer, function new, interval is a float, return self. Last tick, we'll just say is now. No reason. Interval is just going to be copied from the constructor. There we go. And we need a function called tick. It takes immutable reference to self. That's important because it's going to be updating this last tick variable here. And it's going to return a bool, which says if it ticked successfully or not. So we say let now equals chrono local now. If, well, let's see, let elapsed time equals now minus self.lastTick, num in nanoseconds. We're going to go ahead and unwrap that because it's usually going to be much less than a second. And the only reason that it returns none is on overflow, exceeding 263, I believe that's meant to be seconds. I think that's a bug in the documentation. Anyway, we're going to cast that to float. And we're going to multiply it by 1 to the negative 9, which is how many nanoseconds are in a second. 1 to the 9, or 10 to the 9. If elapsed time is greater than or equal to the interval, last tick is now, and we return true. Otherwise, we return false. And there we go. I think that's a functioning timer. Let's go back to main, create a timer. And we're going to say every 60th of a second. There we go. And if we say after the event handling, we will check the timer. If timer.tick, and we're going to do the updating here. For star in stars.ittermute. So actually we need this to be mutable. Star.update. And we give it speed. So we need the speed to be calculated up here. And finally, for every star. And unfortunately, again, we have to iter mutably here. Because, as I mentioned, show is a mutable reference. And that can fail, so we add a question mark. And let's run this and see if we actually did this all right. Oh, I'm in the wrong folder. Crossing my fingers here. Ooh, that's a bad one. Drawing to STL canvas failed. No error message. Well, that puts a wrench in it. First of all, there's an unused import here that bothers me. Let's attach a debugger. I think that's how we do it. I'm gonna overwrite that. We're missing name. Call it launch, why not? Cargo invocation has failed. That's because it needs to be workspace folder /ep 001 starfield. Add a comma here because of JSON. Did not find cargo.toml. Let's see. I'm gonna stick to printf for now. Okay. So we have SX, SY, R. Let's see if those are correct, first of all. And let's run it. Oh, that's PowerShell integrated console. I don't want you. Nope. Don't restart that, please. Infinity. See, that would be a failure, huh? Z goes from 0 to width over 2. 16, 0. What is Z? Z is 167. That's a reasonable number. Is my map function wrong? Oh. Yes, it is. Well, it worked for a moment. We saw stars. Let's get rid of the debugging because that is incredibly slow. And now it's so fast that we can't see the stars. Ah, I know what's wrong. Whenever we are clearing, we are not resetting the draw color to be black. So instead of clear, we're going to say fill. Or no, it's called background now. Color white or black. Import. Ooh, look at that. So you can see that there's a fundamental issue that I've forgotten here. It's all streaking from the top left corner. That's all right, and it's decently easy to fix. Also, there's this white bar that keeps showing up in the far right. Why is that? Let's also compile in release mode just to get some optimizations. Because that is running fairly laggy. I'm not sure if you can notice that. Well, it's just as laggy. You can see the stars are functioning properly. But there is something that we forgot, and let's go ahead and look at that. So there's one line that I ignored here. It is translate. So you could stop here. You could say, you know what, we did good. But that's not good enough for me. We have to translate, and that requires a lot of matrix stuff. So I'll go ahead and cover that in the next episode. Thanks for sticking through this one, if anyone's still watching. I'll see you in the next one.